Hi, I'm Carl, and in this video we're going to have a look at questions 34 and 35 of the third section of the orange booklet. This is a question about dinosaur locomotion, and we're told about two things. We're told about the Freud number and the relative stride length, and there's a graph, figure 1, which shows the relationship between the two. And then figure 2 goes on to explain in a diagram where some of those letters come from. So I've written those out here, and let's start with question 34. It says, if the Freud number of the moving dinosaur depicted in figure 2 were 20 and L were 0.2, its stride length would be of the following closest to what? Okay, so we know how to calculate the Freud number. But actually, if we were to have a look at the graph in figure 1, we can go across to a Freud number of 20 and go up to the line of best fit. Remember to use the line of best fit instead of the individual data points in this. So if we were to read across what the relative stride length would be for something going with a Freud number of 20, we get roughly 6. So let's write that out. We've got a relative stride length of 6. And that's going to be a ratio of the stride length over the height. And we're asked to calculate its stride length. So if we know that the length is 0.2, then that tells us that 6 multiplied by 0.2 equals s, or 6 over 5 is s. And the number which is closest to this, of course this is 1.2, the number which is closest to this is 1.4 meters, which is answer B. And then for 35, it says if L for the dinosaur is 1.2 meters, at what speed would the dinosaur change from trotting to galloping? So this is mentioned that the Freud number will reach 2.5 and then it will change from trotting to galloping. And this is for a ferret, but we're also told that all mammals studied change from one gait style to another at the same Freud number. So we can assume that the Freud number at which this happens, which is going to be v squared over GL, is going to be 2.5. The other unknown we need here is g, and we're told that in the example that's given for the ferret that g is 10 meters per second because it's a gravitational constant. So we've got all the numbers we need. We know v squared, which is what we're trying to find out, over 10 times L, which we're told is 1.2, is equal to 2.5. So then it's just a matter of solving this. So we've got v squared equals 25 times 1.2, so v squared equals 30. Now 30 is not a square number, so it would be difficult to take the square root of this, but the one that's closest to it, and this is how I always approximate these, find a square number which is closest to it. So let's say 25. We know that the square root of 25 is going to be 5, and therefore the square root of 30 has to be greater than 5. And of the answers that we have here, there's only one that's greater than 5, and it's 5.5 meters per second, which would be roughly right. So that means that the answer for this one is 5.5 meters per second, which is answer D. So that was questions 34 and 35. I hope that helped. Thanks for watching.